Welcome back to Xul Podcast, Shooting the Reality. I'm James Caro.
And I'm Emily Lora.
As always, thanks for joining us.
Today we're diving into something both fascinating and unnerving.
Yeah, a little unsettling.
The very real threat of satellite collisions.
Or, as it's formally known, space debris.
You know, it's easy to forget just how much we depend on satellites every single day.
Absolutely.
GPS communication, even weather forecasting.
All those things we take for granted.
All hinge on these systems orbiting our planet.
It's true. And we've got a whole stack of reports here.
From NASA and the European Space Agency.
To kind of help us unpack this whole issue.
Buckle up.
These reports reveal there are hundreds of thousands of debris objects larger than a marble.
Zipping around up there.
And tens of thousands even bigger than a cricket ball.
It's really a mind-boggling number.
It makes you think twice about space travel.
And our dependence on these satellites.
So before we get into it,
Yeah, let's define what we're talking about.
what exactly is space debris?
In the simplest terms, it's any human-made object in Earth's orbit
Okay.
that no longer serves a useful purpose.
So we're talking about defunct satellites,
Spent rocket stages.
even fragments from past collisions.
Oh, and don't forget those little flecks of paint.
So it's essentially space junk.
It
Makes
is.
sense. We've been launching things into space since Sputnik back in 1957,
Cockly.
and not everything comes back down to Earth.
Right, and every single launch, every mishap, every collision
Adds to this problem.
adds to this growing problem
What's really alarming is the sheer speed.
at which this debris travels.
Yeah, in low Earth orbit, we're talking about speeds around 10 kilometers per second.
10 kilometers per second.
10 kilometers per second.
Do you know what that translates to?
That's like 22,000 miles per hour.
Wow.
Faster than a speeding bullet.
It's incredibly fast, and that's why even something as small as a fleck of paint can cause catastrophic damage.
Imagine getting hit by that.
It would be like a miniature explosion,
Okay, you've got my attention.
so we know it's a problem.
But how bad is it really?
Well, let's put it this way. The U.S. Space Force tracks around 27,000 objects
Okay.
that are at least the size of a cricket ball.
Wow.
Then you have over 500,000 objects out there that are marble-sized or larger.
Okay.
But here's the really unsettling part. We're talking about potentially millions,
Million.
if not billions, of smaller pieces.
Oh, wow.
Less than a marble in size, just whizzing around untracked,
So essentially we've got this invisible cloud of shrapnel.
hurtling around in space.
Now I'm starting to see why this is such a big deal.
Absolutely.
Weren't there a couple of major events that made this whole debris problem even worse?
Absolutely. One was the 2007 Chinese anti-satellite test,
Right.
or ASIT.
Yeah.
They intentionally destroyed one of their own satellites, and it created this massive debris cloud.
Thousands of pieces.
Thousands of new pieces added to the mix right in that crucial low Earth orbit,
Where a lot of our satellites are.
where so many of our vital satellites operate.
And if I remember correctly, there was a collision between two satellites just a few years later.
You're right. In 2009, the Iridium-33 and Cosmos 2251 satellites collided.
Right.
That was a major turning point,
It really was.
significantly increasing the amount of debris, especially in that already crowded low Earth orbit.
So we've got this debris from the early space age, and then these events that just kind of added fuel to the fire.
Yeah,
Now we're launching more satellites than ever.
right.
Huge constellations of these smaller satellites like the CubeSats.
The CubeSats,
Are they contributing to the problem too?
they are definitely part of the equation.
Okay.
CubeSats and these larger satellite constellations, while undeniably useful for things like communication and Earth observation,
Sure.
are adding to the congestion, especially below an altitude of about 700 kilometers.
There's a sure trade-off.
It's a trade-off we have to consider very carefully.
We've painted a pretty stark picture here.
Yeah.
Well, what are we actually doing about it?
Well, there are a couple of main approaches.
First, there's orbital debris mitigation.
What is that?
This is all about preventing the creation of new debris
Okay.
in the first place.
So being more responsible,
So designing satellites for safer disposal, coming up with end-of-life plans for them,
like good space citizenship.
and generally being more responsible about what we launch into space.
What's the other approach?
That's where we get into actually cleaning up the mess.
Okay.
It's called orbital debris remediation.
Orbital debris remediation.
And this is where things get really interesting because we're talking about actually removing that existing debris from orbit.
Are we sending up tiny astronauts with little space brooms?
It's not quite that simple.
Okay.
When you're dealing with something like a defunct satellite that's large debris,
Okay.
removal gets pretty complex and expensive.
I can imagine.
One option is controlled reentry,
Okay.
where you essentially use a spacecraft to tug the debris down into the atmosphere.
Okay.
So it burns up safely, but that requires very powerful and sophisticated spacecraft.
It's a high cost.
High cost. What if we just let them fall on their own?
That's called uncontrolled reentry.
Oh, okay.
It's definitely cheaper,
Yeah,
but it also carries a significant risk.
I bet.
There's always the chance that debris could survive reentry and land in a populated area.
Right.
Not exactly ideal.
Not ideal.
So there's a big cost-benefit analysis involved.
So it's like choosing between a controlled demolition and playing a risky game of space junk lottery.
Yeah,
But what about all those smaller pieces, the ones we can't even track?
that's the million-dollar question, literally.
Yeah.
Removing those smaller pieces, those 1 to 10 centimeter fragments, is even more challenging.
Right.
Believe it or not, lasers are actually one of the most promising solutions
Brilliant.
being explored right now.
Lasers.
Lasers. It might sound like science fiction,
It does a little bit.
but using lasers to combat space debris
Okay.
is a real area of research.
We're talking about zapping space junk with beams of light.
We are.
Sign me up. How does that actually work?
It's fascinating. There are two main types of laser systems being developed:
Okay.
ground-based and space-based.
Ground-based.
With ground-based lasers, you have powerful lasers stationed here on Earth
Okay.
that are aimed at debris.
Got it.
The laser essentially vaporizes a tiny amount of material from the debris,
Okay.
which creates a small amount of thrust.
So just nudges it out of the way.
You're on the right track.
Wow.
Those lasers have to be incredibly powerful to reach debris in orbit.
They do.
And there's the challenge of atmospheric interference.
Right.
But that tiny bit of thrust from the laser can change the trajectory of the debris
Enough to...
enough to cause it to fall into the atmosphere and burn up.
Got it. So what about space-based lasers?
Exactly.
Putting lasers on satellites.
The advantage of space-based lasers is they're closer to the debris,
Makes sense.
so they don't need to be as powerful to achieve the same effect.
Okay.
Plus, you eliminate the issue of atmospheric interference.
Right.
There are several projects in development looking at this.
So we've gone from tiny astronauts with brooms to lasers in space. What other solutions are scientists cooking up?
Well, one concept that sounds simple
Okay.
but is actually quite challenging
Okay.
involves these massive net-like structures
Hi.
called space sweepers.
Space sweepers like giant nets that scoop up the debris.
You're on the right track,
Okay.
but there are a lot of logistical hurdles.
Like what?
First of all, these sweepers would have to be enormous.
I can imagine.
To capture a significant amount of debris,
Right.
deploying and controlling them would be incredibly complex.
Not to mention expensive.
Not to mention expensive.
And then there's the risk of the sweepers themselves turning into more debris.
The irony.
That's pretty funny.
So maybe space sweepers aren't the most practical solution.
Okay, what about recycling?
Recycling?
I remember reading about turning space junk into useful resources.
That's one of the most exciting frontiers in this field.
like space alchemy.
Imagine turning those old satellites and rocket parts into valuable materials.
For building new spacecraft.
For building new spacecraft, or even for use here on Earth,
Right. How would we actually do that?
it would require developing in-space manufacturing capabilities.
That's a whole other area of research.
Well, there's a whole other area of research and development.
Right.
One promising concept is to convert debris into propellant for other spacecraft.
So we're talking about turning space junk into fuel.
We are.
That's incredible. It would solve two problems at once.
Exactly.
Reducing the debris and the need to launch propellant from Earth.
Which is incredibly costly and resource intensive.
What about the environmental impact?
There are also potential environmental benefits.
Okay.
When debris re-enters the atmosphere uncontrolled, it can release harmful chemicals.
Why?
Recycling the debris in space would prevent that.
So it's good for the space environment and good for Earth.
A win-win.
But is it economically feasible?
That's the big question.
Yeah.
While the concept of recycling debris is incredibly attractive, the technology for in-space manufacturing is still in its early stages.
Right.
It would require a significant investment to make it a reality.
I bet.
Right now, it doesn't appear to be more cost-effective than other methods of debris remediation,
Okay.
like the lasers we talked about earlier.
Right.
But this is a rapidly evolving field.
So something to watch closely. What about just moving the debris out of the way? Is that an option?
It is especially for those large pieces that pose the greatest risk of collisions.
Like defunct satellites.
It's like defunct satellites. There are techniques called just-in-time collision avoidance, or JCA,
JCA?
and long-duration trajectory modification, LDTM for short.
LDTM, those are some serious acronyms. Break it down for me.
Think of them as ways to give those large pieces of debris a little nudge
Okay.
to change their course. We're not talking about massive changes.
Just enough to avoid a collision.
Just enough to avoid a potential collision with another object.
So like a cosmic game of billiards?
That's a great analogy.
I like that.
It involves using technologies like lasers or even small rockets
Okay.
to gently nudge the debris into a slightly different orbit.
So JCA is for immediate threats.
JCA is for immediate threats, those collisions that are predicted to happen within a few days or weeks.
Okay.
LDTM is for longer-term adjustments,
Okay.
where you might have months or even years to make smaller, more gradual changes
Sure.
to the debris' trajectory.
It sounds like incredibly precise work.
It does.
What if something goes wrong?
That's a valid concern, and it highlights the fact that any method of debris remediation has to be approached with extreme caution
Right.
and precision.
Makes sense.
There are always risks involved,
Sure.
but the potential benefits of preventing a catastrophic collision often outweigh those risks.
I can see that.
It's a delicate balance.
It sounds like we've got this toolbox of options for dealing with this.
Right.
Lasers, sweepers, recycling, and these nudging techniques, any of these emerging as the most promising?
Lasers are definitely a leading contender, particularly for removing those smaller, untrackable pieces.
Okay.
They offer precision and scalability, and the technology is rapidly advancing.
What about the other options?
Well, we also have controlled and uncontrolled reentry for larger debris.
Right.
Each comes with its own set of costs and risks.
Right.
And then there's the exciting possibility of recycling debris,
Yeah,
which has some great benefits, but still needs more development.
sure.
It's unlikely that any single solution will be the silver bullet.
Right.
We'll probably need a combination of approaches to effectively address the multifaceted debris problem.
It all comes back to data.
Yes,
We need to know what's up there, where it's going, how fast it's traveling.
absolutely.
Without accurate data, we're essentially shooting in the dark.
We need to drastically improve our space situational awareness.
Okay.
That means better tracking and characterization of the debris,
Especially,
especially those smaller, untrackable pieces that pose a hidden threat.
it's like trying to clean up a messy room in the dark.
That's a great way to put it.
You know, it's there, but you can't really see it.
We need more advanced sensors,
Okay.
both on the ground and in space, to detect and track these objects.
Right.
We also need to improve our data processing capabilities.
Right.
This is a massive, big data challenge.
Big data meets the final frontier. It sounds like we need a global effort to tackle this.
We do.
No single country can do it alone.
No.
What are the biggest challenges to improving our space situational awareness on a global scale?
One challenge is the sheer number of objects we need to track.
Millions.
Millions of pieces of debris ranging in size from tiny flecks of paint to massive defunct satellites.
Right.
Detecting and tracking all of that is a monumental task.
Yeah.
Many of them are very small and difficult to detect with current technology.
Right.
We need more advanced and sensitive sensors,
Okay.
and we need a lot of them.
Like finding a needle in a haystack, except the haystack is in space and moving at 22,000 miles per hour.
That sums it up perfectly.
That's right.
And there's also the challenge of data sharing and international cooperation.
Right.
Space debris doesn't respect national borders.
It doesn't.
So we need countries to work together and share their tracking data.
So it's like a global game of cosmic dodgeball.
Exactly.
Everyone needs to be on the same team.
And it's not just about avoiding collisions.
Right.
It's also about ensuring the long-term sustainability of space activities.
So we're at a fork in the road.
We are.
One path leads to a future where space is accessible.
A place where we can explore, learn, and innovate,
The other path leads to a future where space becomes a no-go zone.
littered with debris and too dangerous for exploration,
The choices we make today,
will determine which path we take.
we can't afford to be complacent.
We can't.
We need to act now.
Invest
Invest in the technologies
in the international collaboration
that will ensure a safe and sustainable future.
for space exploration,
Well said. We've covered a lot of ground here, from lasers to space sweepers.
to the need for global cooperation.
But there's one aspect we haven't touched upon yet. The economic impact of all this. It's
Yes.
not just about science and technology, it's about the bottom line.
That's a crucial point.
Yeah.
The debris problem doesn't just pose a risk to spacecraft.
Right.
It also has a significant impact on the economics of space exploration and utilization.
Space travel becomes more expensive.
More expensive.
And risky.
More risky.
Who's going to want to launch $1 billion satellite?
If there's a good chance it's going to get taken out by a piece of space junk.
Right.
The increased risk of collisions drives up insurance costs
For satellite operator.
for satellite operators, which in turn makes space-based services more expensive for everyone.
Right.
And it's not just about the cost of replacing damaged satellites.
Right. It's the economic disruption that can
No.
occur.
If a vital satellite is taken out of commission
Imagine if GPS went down
for a day.
because of a debris collision.
Yeah, the economic impact would be enormous.
It would.
It's a stark reminder that the debris problem isn't just an abstract scientific concern.
Right.
It has real-world consequences for all of us
The ripple effects could be felt.
throughout the global economy.
It's like buying an insurance policy for our future in space.
Exactly. And as the space economy continues to grow, the economic benefits of addressing the debris problem
Will become more significant.
will only become more significant.
It's not just about avoiding a space junk apocalypse.
Right.
It's about ensuring that space remains a viable and thriving economic frontier.
It is.
We've talked about international
In
cooperation,
terms of data sharing,
but what about the legal aspects of this problem?
mhm,
We've touched on guidelines and best practices.
Right.
Are those enough? It seems like we need more than just a handshake agreement for something like this.
you're right.
What's the current legal landscape?
When it comes to this issue,
Yeah.
that's a great question, and one that often gets overlooked.
Okay.
The foundation of international space law
Okay.
is the Outer Space Treaty,
The Outer Space Treaty.
signed back in 1967.
Wow. Long time ago.
It was a landmark agreement,
Sure.
but it was drafted before the debris problem became as significant as it is today.
So we're trying to manage a 21st century problem
With a legal framework
with a legal framework from the 1960s.
in the 1960s, that's right.
That sounds like a recipe for trouble.
It definitely presents some challenges.
Okay.
The Outer Space Treaty focuses on things like prohibiting the placement of weapons of mass destruction in space
Right.
and ensuring that space exploration benefits all humankind.
Makes sense.
It touches upon liability for damages caused by space objects,
Okay.
but it doesn't provide specific regulations for debris mitigation.
It's a bit of a legal gray area.
Exactly. And as the problem grows
Right.
and the space environment becomes more congested,
Right.
the need for a more robust legal framework becomes more urgent.
What are some of the ideas to strengthen the legal framework?
There's a growing movement to establish binding international regulations for debris mitigation.
Okay.
We're talking about things like mandatory deorbiting requirements for satellites.
So instead of just recommendations
Right.
or guidelines, there would be actual rules
With consequences.
with consequences for noncompliance.
So we need to move from a system of space etiquette,
Space law
space law,
with real teeth.
with some teeth.
Yeah.
I imagine getting all the countries on board with that would be pretty difficult.
It's a huge diplomatic challenge.
Yeah,
Space is a global commons,
right.
and any attempt to regulate activities in space requires international consensus.
Yeah.
There are a lot of competing interests and perspectives to navigate.
So a long and complicated process.
It would be, but the alternative, a space environment so choked with debris that it becomes unusable,
Mm-hmm.
is simply unacceptable.
That's a good point. What
Yeah.
about liability for debris collisions?
Mm-hmm.
I imagine that gets pretty complicated.
It does. Let's say a piece of debris from a satellite launched by one country damages a satellite from another country.
Right.
Who's responsible for the damage?
Yeah.
Who pays for the repairs or replacement?
These are complex questions
Totally
that
correct.
current international law doesn't fully address.
It's like a giant game of cosmic bumper cars
Exactly.
with potentially huge financial and political ramifications.
It's a reminder that space debris isn't just a scientific or technological issue.
Right.
It has profound legal and economic dimensions
That we need to consider.
that need to be carefully considered as we move forward.
This has been an incredibly insightful deep dive.
It has.
We've gone from the nuts and bolts of what space debris is
To the cutting-edge technologies.
to the cutting-edge technologies being developed to address it.
We've even touched upon the complex legal and economic implications.
Yeah, it's clear that this is a multifaceted issue
It is.
with no easy solutions.
And it requires a holistic approach.
Right.
We need scientists and engineers developing innovative technologies, policymakers crafting effective regulations,
And diplomats.
and diplomats fostering international cooperation.
Yeah, everyone has a role to play.
Everyone has a role to play in ensuring a sustainable future for space exploration.
It's not just about cleaning up the mess.
It's about changing our mindset.
It's about changing our mindset and adopting a more responsible approach to space activities.
Absolutely. We need to become better stewards of this incredible resource.
And that starts with awareness.
It does.
The more people understand the challenges and the potential consequences of inaction,
The more likely
the more likely we are to find solutions. So it's time to wrap up this episode.
of Xul Podcast, shooting the reality.
We've only scratched the surface.
But as with any deep dive,
This is a conversation that needs to continue.
we hope you found this exploration of space debris informative and thought-provoking.
We encourage you to do your own research, stay informed,
And get involved.
and get involved in the conversation about how we can ensure a sustainable future for space exploration.
Share your thoughts and comments below. We're always eager to hear from you.
And keep the conversation going.
And if you enjoyed this deep dive,
Don't forget to subscribe to Xul Podcast, Shooting the Reality,
for more,
for more explorations into the topics that matter. Until next time.
keep looking up and stay curious.